Again, welcome to Unit 6, Lecture Part 3. Again, this is a review of a basic algebra. Today, we are going to cover rational expressions. Again, we are going to cover rational expressions. Our main objective, first, we're going to define what a rational expression is. Then we're going to have an example how to simplify rational expressions. Also, how to multiply and divide rational expressions. Also, how to add and subtract rational expressions. And then last but not least, simplify complex fractions. So again, in these lectures, we're going to cover the concept of rational expressions, both addition, subtraction, multiplication, and also division of a rational expression. So first, what is a rational expression? We are given a definition here. For example, if we have x and y variables, x and y, and these two variables are real numbers, then the quotient of s and y, which is s divided by y, as far as y is not equal to 0, is called a fraction. So the concept of a fraction is dividing two values. We have the numerator, which will be the x value in this case, and also the denominator. So rational expression concept is having two variables, or it can be two expressions dividing each other. So an algebraic fractions are quotients. So algebraic fractions are quotient of algebraic expressions. Now, if the expressions are polynomials, then we call the fraction a rational fraction or a rational expression. So the concept we already talked about, what is a polynomial? A polynomial is when you have an algebraic fraction with more than one term. Example would be 3x squared plus 5 is a polynomial, or 3x squared plus 2y plus 10 is a polynomial. So we're going to see an example soon. Here we said if A, B, and C, and also D are real numbers, and we make sure that the denominators are not 0, then we have what we call the fractions. So equality of a fraction here, we have A by B equal to A, C by D. So we said again, if A, B, C, and D are real numbers and no denominators are 0, in this case, if B and D are not 0, and A by B equal to A by C, this is called the equality of a function, which we're trying to say is that A divided by B is equal to C divided by D. And we know we can't divide a value by 0, so B and D shouldn't be 0. And that's what it is. So if and only if A, D equal to BC. And what we did here is what we normally call cross multiply. So if I have A divided by B equal to C divided by D, I can cross multiply by multiply A by D equal to C by D. So here we get cross multiply A multiplied by D equal to B multiplied by C. And when we are solving again rational expression, we can cross multiply the terms. So that's the fundamental property again of a fraction. If I have AX divided by BX is equal to A by B, because X will cancel each other. Again, if we have A by B equal to C by D, we can cross multiply. So A multiplied by D equal to B multiplied by C. And that's what we have here. And if I have AX divided by BX, since X divided by X, we can cancel the X. So we get A by B. We also have a multiplication and division of fractions, some few rules here. If I have A by B multiplied by C by D, it's the same as multiply all the numerators together and multiply all the denominators together. So we get A times C will give me AC here, divided by B times D, BD. And that's the rule for multiplication of a rational expression. So we can see that this rule is almost the same as the fraction rules. Example is if I have a by b divided by c by d, I can turn the second fraction upside down and change the division sign to multiplication. So this will equal to a by b multiplied by d by c. We can see that we turn the c by d upside down, which gives us d by c. Then we change the division to multiplication. And this is exactly fraction division rule. Then addition, subtraction of fractions. If the denominators are common, for example, here we have a by b plus c by b. So b is common. So we can keep 1b and then add the numerators. The same thing if it's the numerators are minus, example here, a by b minus c by b. B is common, so we keep b, then we say a minus c. Now, if the denominators are not common, then we find what we call the LCD. So an example given here, we have 2a divided by 3 equal to 4a divided by 6. First thing I can do, I can cross multiply. So I can get 2a times 6 equal to 4a times 3. And that's what we have here. And that can give us 12a equal to 12a. So they are the same. Or another example, if I have 6sy divided by 10sy, we can cancel x and also y and y. So we get 6 by 10. But in 6 by 10, we know 2 can go into 6 is 3, and 2 can go into 10 is 5. So 2 is divisible by 6 by 10. So finally, our answer will be 3 by 5. Because the s cancel each other up and down, or the numerator and denominator, we have x, so they cancel each other. Also y, we have numerator y, denominator y, so we can cancel. Then 6 divided by 10, 2 is divisible by 6 and 10. So 2 going to 6 is 3, 2 going to 10 is 5. So finally, our answer will be 3/5. So a rational expression is in a lowest term. Again, if all the factors common to the numerator and the denominator have been removed. As we saw the extra example, let's go back once. Here we can say that 6xy divided by 10sy, its lowest factor will be 3 by 5. And we cancel all the necessary between the two on the lowest. So that's what we mean here. A rational expression is in lowest term if all the factors common to both the numerator and the denominator have been removed. So if I have 2 divided by 4, the lowest term will be half because 2 is divisible by 4 and also is divisible by 2. So 2 by 4 will give me 1 by 2. And that will be the lowest term for 2 by 4. So to simplify a rational expression, it simply means that we have to write our final solution in its lowest term. So we keep cancel. If there's a division, we use the division rule for fraction. If there's a multiplication, we use multiplication rule. If it's addition, subtraction, we have to use the rules also for that. So now next step is simplify rational expressions. So here again, we said if A and B represent the real numbers and there are no division by 0, then as we said earlier, A divided by 1 is the same as A. Or A divided by A, they will cancel each other, so the answer is 1. Or A divided by B is the same as having negative in both sides, so negative A over negative B. Or we can write in the form of A negative B equal to negative AB. And again, we're going to solve example now. So now our example here, we have s squared minus 2xy plus y squared divided by y minus x. And here we say that s shouldn't be equal to y, because if s equal to y, the denominator will be 0 because it's y minus x. So if s is 5 and y is 5, then the denominator will be 0. And we cannot divide the value by 0. So solution is, first we can see here we have a trinomial. So first we can see if we can be able to factorize. Now if we have minus and plus between terms, we cannot cancel. So for example, I cannot cancel y by 2sy because it has minus. But if it's multiplication in both sides, then we can cancel. So that's why we want to factorize, if possible, this trinomial. So we say we factor the trinomial in the numerator. First, we factor -1 from the denominator and divide the common factors of s and y. So this is what we get. S squared minus 2sy plus y squared. If we do the factorization by a trinomial, we will get s minus y times s minus y. Again, we went through how to factorize polynomials already. So for example, yes, s squared. So I'll put 1x and 1s. Now find a value that when you multiply, you get y squared. When you combine, you're going to get minus 2xy. And that's what we did here. So we get s minus y, another s minus y. Now if we open the parentheses, we will get the same as s squared minus 2sy plus y. This is actually a perfect square also. Since we know a squared minus 2ab plus b squared will give me a plus b all square, or a plus b times a plus b. Yes, minus. So it will give me s minus y times s minus y. Or if you like, you can factorize it also, you get the same answer. So now we know that here we have y minus x. At the numerator, we have s minus y. So I multiply -1 by everything at the denominator. And that changes it to s minus y with -1 outside. So we can cancel 1, s minus y. And our answer will be s minus y divided by -1. Now in order to get +1, then we have to interchange s minus y. We multiply negative by everything, we get negative times positive x will give me negative x. Negative times negative y will give me positive y. So sometimes we can write the answer as s y plus, y minus x. Or we leave the answer as minus s minus y. After we cancel this, we bring the minus to the front. And any value divided by 1 is the same value. So next we do the multiply and also division of rational expressions. We already know the rules for division of, again, rational or fractions. So here, this is my question now. We have 2x squared minus 5x minus 3 divided by 3x minus 1 times 3x squared plus 2x minus 1 divided by x squared minus 2x minus 3. This is divided by 2x squared plus x divided by 3x. So the first thing we can do is to see if we can be able to factorize something. And first, I will change the division here to multiplication. So which means if I write multiplication here, this division will be 3x divided by 2x squared plus x. And when you change division to multiplication in fractions, you turn the value after the sign upside down. In this case, I'm changing this division to multiplication. So the next term, which is 2x squared plus x over 3x, I'll turn it upside down. So next we're going to get here 3x over 2x squared plus x. We turn it upside down. So we have the same term. Now we can try to cancel things out if it's possible. So far, I can't see nothing I can cancel. So I will need to factorize, hopefully, some of the terms. So we can see what we did here. We were able to factorize some of the terms. 2x squared minus 5x minus 3. We use the techniques that we learned earlier. Factorize trinomial. So we get s minus 3 times s plus 1. Then the same thing applied to 3x squared plus 2x minus 1. We factorize it, we get 3s minus 1, s plus 1 times the 3x. And here also the same thing, we factorize s squared minus 2x minus 3. That gives us s plus 1 times s minus 3. Then we have 2s squared plus s. We can bring s is common here. So we bring s outside. Then we divide 2s squared by x. That gives us 2x. Then s divided by x, that will give me 1. So we have 1 here. So we almost finished now. Now when we look, we can cancel many things. S minus 3, cancel s minus 3. And 2s plus 1, we have 2s plus 1 at both numerator and denominator. They cancel each other. Then the same thing, we have s plus 1 cancel. We'll also cancel x. So at the end, what we've been left with will be 3. Actually, it's only 3 left. So we can see our final answer. Again, we give us 3. So next is a adding and subtraction of rational expressions. The rule here, I think the most important thing we said earlier was the least common denominator. If the denominators are not the same, then we need to find the LCD. So what is LCD? This example given here. If I have 1 over x squared minus 4 plus 2 over x squared minus 4x plus 4. I want to solve this problem. So the first thing I will do is to combine the two terms. But we can see that the denominators are different. So we can try and factorize the trinomial. This will give me a difference of 2 squared. S squared minus 4 is the same as s squared minus 2 squared. And here I have s squared minus 4s plus 4. We can also factorize it. So we saw that s squared minus 4 is s plus 2, s minus 2. Then when we factorize s squared minus 4s plus 4, we get s minus 2 and also another x minus 2. Because this is perfect square to give me s minus 2 all square. So if we know this, then we know the LCD. Remember, we have the perfect square, we have s plus 2. So the LCD will be s plus 2, s minus 2 all square. And then from here, this is the question. We can write our expression s plus 2, s minus 2, s minus 2, and s minus 2. And then we can find the least common factor. Here we can see that is again, it should be s plus 2, s minus 2 square. So if I divide s plus 2, s minus 2 all square by the denominator, it will left it 1 s minus 2 because here we have s minus 2 square. Here we have only s minus 2. And the top is only, the numerator is only 1. So when I divide, I will get the answer to be s minus 2 and I'll multiply it with 1. The same thing apply here. We have s minus 2 times s minus 2, so which means we have s minus 2 square. So s plus 2, s minus 2 square divided by s minus 2 square will be left with only s plus 2. So I'll multiply s plus 2 by 2 and I get 2s plus 2. And I write down the denominator also. So from here, we try and open the parentheses. And we get s minus 2 plus 2s plus 4. And when we simplify it, we get 3x because like term is s plus 2s, 3s. 4 minus 2 will give me 2. And here I have s plus 2, but s minus 2 times s minus 2 will give me s minus 2 all square. So that will be our final solution. Next, we're going to simplify a complex fraction. A complex fraction normally is a fraction that has fraction in its own numerator or fraction in its own denominator. So this is an example of a complex fraction. You can see that we have a fraction again in the numerator and also another fraction in the denominator. So to simplify this, we can find the LCM of s and y. Then the answer we get, the goal is to combine s by 1 by x plus 1 by y. So this is what we did here. So we use sy for both numerator and denominator. Then we cancel it out because s will cancel, y will cancel. So finally we get, instead of 1 over s plus 1 over y, it will give us y plus x. And we do the same thing down here. Y cancel y, so we have only s squared. And here we have s over y. So that's why we get syx over y here. And since y cancel each other, we get only s times s, which is s squared. And here also, the same thing, we are using fraction rules. I can say sy divided by x plus sy divided by y. And that's what we have here. Then when we cancel, we get y plus x. So our final solution will be y plus x divided by x squared. So we can also use another method to simplify the complex fraction. So the same problem we have here, instead of finding the LCM and etc., we decided that, okay, we have sy. The best way to combine is this. Since we have sy, the common denominator will be sy, because there's x in the left side and y in the right side. So we get, on the left side, we get s times y. On the right side, we get y times x. Then we have y and x at the numerator, because sy divided by s will be y times 1. Sy divided by y will be s times 1. So from here, we can try to simplify by combining the two terms. We have sy, so they are common, sy, then y plus x. Then we can use the fact that any fraction indicates a division. So this is a division here, this is a division. So we break it down, y plus s over sy divided by s and y, so that we can do one division at a time. And at the top, you can see that y is common, y plus sy. So we take y out, and we get y plus x. So the final solution, when we cancel the y, we get y plus x over s squared, which again is the same as the previous method we used also. So this will be the conclusion again of our lecture 6, unit 3, which is the final lecture for rational expressions. And again, wish everybody the best. Thank you.